Hi everyone, I'm Simone and today we'll discuss a crucial topic for all modern organizations: cloud cost optimization. In today's digital era, cloud technologies are the backbone of countless organizations. As businesses increasingly depend on cloud services, managing cloud expenses has become crucial. According to Gartner's November 2023 report, global spending on public cloud services is expected to surge by 20.4%, reaching $678.8 billion in 2024. This cost can spiral out of control as the operations scale up. Optimizing cloud spending is vital for cost efficiency, better budget management, and enhanced return of investment. Luckily, the open source community has the same needs and provides several powerful tools to help organizations control their cloud expenses while maintaining optimal performances. Join us as we explore the top 10 open source tools that can transform your cloud cost management strategy. Please note that this is not a ranking. It is just a non-preferential overview, and we suggest you to delve deeper into the solution that match specifically your needs. Kubernetes is a leading open source container orchestration platform. It excels at automating the deployment, scaling, and management of containerized applications. By streamlining containerized workloads based on demand across a cluster of machines, Kubernetes enhances availability, scalability, and resource efficiency. It's a true powerhouse container for orchestration. Kubernetes offers several features that help reduce cloud costs. Kubernetes includes open source tools like horizontal pod autoscaler and cluster autoscaler, which dynamically adjust the number of containers in use. This prevents over-provisioning, ensuring companies only pay for the resources they actually use. Kubernetes boosts developer productivity by simplifying deployments, rollbacks, and scaling. This allows developers to focus on building applications rather than managing cloud infrastructure. Kubernetes enables horizontal scaling, distributing workloads across multiple nodes. This optimizes resource usage and reduces costs. Companies like Netflix, Spotify, and Pearson's use Kubernetes to manage their containerized microservices and autoscaling. By leveraging Kubernetes, these companies have significantly reduced their cloud infrastructure costs. Terraform is an infrastructure as code tool that defines infrastructure resources such as servers, storage, and networks in declarative configuration files. This approach facilitates automation, repeatability, and cost optimization. Its use case includes manages Kubernetes, virtual images, and network infrastructure. Keep note that as November 2023, Terraform is no longer open source due to HashiCorp's acquisition by IBM. For a fully open source alternative for cloud costs optimization, consider OpenTofu. Terraform offers a comprehensive view of your infrastructure, helping to identify and eliminate unused or underutilized resources. You can also define resource configurations with exact specifications to prevent over-provisioning. Automation minimizes mistakes, while code-based changes ensure quick, consistent application. Integrating Terraform provides early cost estimates based on configurations, enabling informed decisions about resource types and sizes. Automated checks can help maintain budget limits. Companies like Deutsche Bank or GitHub use Terraform to simplify infrastructure provisioning across multiple cloud providers, enhancing efficiency and reducing costs. Grafana is an open source monitoring and observability system renowned for its robust visualization capabilities, allowing you to analyze and understand data from various sources, including cloud services. Now let's explore how Grafana can help identify cost inefficiencies and optimize resource usage. Integrate Grafana with cloud providers like AWS, Azure, and GCP to ingest cost data. Create custom dashboards to display cost metrics such as hourly, daily, or monthly spending by service, project, or region. You can also utilize heat maps and other visualization to spot cost spikes, trends, and anomalies. Grafana allows you to delve into specific cost components such as CPU, storage, network usage, or database instances. Correlate cost data with infrastructure metrics to understand the root cause of cost variations. This helps identify idle resources or inefficient configurations that increase costs. Configure alerts to trigger when spending exceeds predefined thresholds or where anomalous cost patterns emerge. Of course, early detection of potential overspending enables corrective actions such as scaling down resources or optimizing configurations. Companies using AWS can leverage Grafana to create personalized dashboards that display total daily spending on AWS services, cost breakdown for EC2 instances, S3 storage, and Lambda functions. While Grafana is a powerful open source tool, it requires setting up data sources and configuring dashboards for detailed cost analysis, effective cost monitoring, and optimization. Prometheus is an open source monitoring and alerting toolkit designed for cloud-native platforms. It collects and analyzes metrics from your cloud infrastructure, enabling efficient monitoring of resource utilization and cost reduction. Prometheus is a powerful real-time monitoring tool with alerting capabilities, making it highly effective for cost optimization. Prometheus helps users understand resource efficiency by tracking metrics such as CPU, memory, and storage usage for cloud resources. Prometheus can identify resources with consistently low utilization, indicating potential over-provisioning and opportunity for cost savings. By combining Prometheus metrics with cost data from your cloud provider, you can pinpoint which resources are driving costs and how changes in resource usage impact your cloud bill. Prometheus is widely used to monitor EC2 instances. Companies have discovered that 20% of instances have consistently low CPU utilization, prompting them to right-size these instances to smaller sizes, thus saving on compute costs. A notable example is SoundCloud, which uses Prometheus for effective monitoring and cost optimization. Apache Kafka is an open source tool developed by LinkedIn for distributed data streaming. While it may not be primarily known for cost savings like some other tools, it offers several features that can significantly reduce cloud infrastructure expenses, especially when handling large volumes of online data streams. Notably, over 80% of Fortune 100 companies use Kafka. Kafka acts as a buffer between data producers and consumers, known as decoupling. This allows producers to send data at their own pace without affecting consumers and vice versa, reducing resource consumption on both ends and leading to potential cost savings. Kafka log compaction reduces storage costs by eliminating duplicates and retaining only the latest version of data, optimizing long-term data retention. Additionally, tiered storage options, such as those offered by Confluent Cloud, minimize expenses by offloading older data segments to cheaper cloud object storage. Kafka allows dynamic scaling of clusters in the cloud based on data volume and processes needs. This prevents over-provisioning and reduces the cost of idle resources. LinkedIn, the innovator of Apache Kafka, is a prime example of using the tool to optimize data processing workflows and reduce cloud expenses. Elasticsearch is a distributed search and analytics tool designed to efficiently handle large volumes of data. As an open source solution, it enables organizations to manage and analyze datasets cost effectively, while some advanced features require a paid subscription. Elasticsearch inverted indexes optimize searches for specific terms, reducing the data scanned and lowering resource consumption. Additionally, Elasticsearch ILM, which stands for Index Lifecycle Management, automates moving older data to cheaper storage tiers, optimizing storage costs for data with varying access needs. Elasticsearch clusters can be scaled horizontally by adding more nodes, allowing you to handle growing data volumes without sacrificing performance. This approach eliminates the need for expensive hardware upgrades. Elasticsearch can replace traditional search appliances, which can be costly and offer limited scalability. Summarize data into single documents and then archive or delete the original data to save on storage costs. Elasticsearch is widely adopted for its cost-saving features such as efficient data storage and horizontal scaling. For instance, a company using Elasticsearch to store and analyze website logs can implement ILM to move older logs to cheaper cold storage, significantly reducing storage costs. Similarly, an e-commerce company can use Elasticsearch to power its search engine, leveraging its efficient storage and indexing capabilities to handle large product catalogs and high search volumes without incurring high infrastructure expenses. For those on the AWS cloud platform, the AWS OpenSearch service offers a managed solution with similar functionalities and potential cost-saving benefits. Hadoop is a Java-based distributed processing framework designed for big data analytics and processing. Its scalable and fault-tolerant architecture helps reduce cloud resource costs. Hadoop offers several cost-saving benefits for data processing and storage in the cloud. Hadoop clusters can be easily scaled up or down, allowing organizations to pay only for the resources they use, particularly in cloud environments with on-demand pricing models like Yarn, which stays for yet another resource negotiator. As an open source tool, Hadoop eliminates the licenses costs associated with proprietary data processing solutions. Hadoop's data lake architecture can store large volumes of structured, semi-structured, and unstructured data in a centralized repository. This reduces data silos and simplifies data management, potentially lowering storage costs. Companies like Adobe, LinkedIn, and Facebook use Hadoop to optimize data workflows and reduce costs. For instance, an organization might use a cloud-based Hadoop cluster to process large amounts of user activity data and social media sentiment. By leveraging on-demand pricing and scaling the cluster based on usage patterns, they can also optimize cloud spending effectively. OpenStack is an open-source cloud computing platform enabling organizations to create and manage private clouds, offering a cost-effective alternative to paid cloud tools through efficient resource utilization. These are some cost-saving features of OpenStack. OpenStack Compute Service allows users to create and manage virtual machines, serving as an alternative to proprietary compute services like Amazon EC2 or Google Compute Engine, potentially reducing virtual machine provisioning and management costs. Swift for object storage and Cinder for block storage offer alternatives to proprietary storage solutions like Amazon S3 or GCP storage, helping organizations avoid vendor lock-in and reduce storage costs. Distributed Resource Scheduler distributes workloads across multiple nodes based on resource usage, optimizing resource utilization and reduces costs. OpenStack allows the use of open source tools to monitor and manage infrastructure, providing detailed control over large volumes of resources and reduces costs. Big organizations like IBM, Walmart, VMware, and NASA use OpenStack for cost optimization. A trend among these organizations is integrating OpenStack with Kubernetes to leverage OpenStack infrastructure management and Kubernetes container orchestration. Docker is an open source containerization platform that helps in managing containers and optimizing cloud expenses by enhancing resource utilization and streamlining deployments. But how Docker could impact for cloud cost optimization? Containers use fewer resources than virtual machines, leading to lower compute, memory, and storage costs. By running more containers on fewer servers, you can optimize resource usage and reduce the number of required instances. Docker containers are lightweight and quick to start, speeding up application deployment and scaling. This minimizes the time applications spend idle, reducing cloud costs. Docker ensures consistent deployment across development, testing, and production environments, reducing the need for separate infrastructure for each stage and saving cloud resources. Docker supports breaking down applications into smaller independent services, allowing for easy scaling and resource allocation based on individual service needs, optimizing cloud costs further. Big organizations like Google, AWS, and ThoughtWorks use Docker to lower cloud costs by reducing the overhead associated with virtual machines and improving deployment efficiency. For example, a company using Docker for its microservices architecture can scale individual services based on traffic patterns, optimize resource utilization, and reducing costs compared to monolithic applications on virtual machines. Docker Swarm, which is a Docker native container orchestration platform, also helps manage containerized applications at scale, providing efficient load balancing and further cost-saving opportunities. Apache Spark is an open-source distributed data processing engine that efficiently handles data engineering, data science, and machine learning tasks on single-node machines or clusters. It is particularly effective for managing large datasets and can reduce cloud costs for big data analytics and processing. Tools like Kubernetes can be used to configure resource allocation for different stages of data processing jobs, ensuring efficient resource utilization and preventing over-provisioning. Spark's ability to handle various big data tasks, including batch processing, real-time streaming, and machine learning, eliminates the need for separate tools and their associated infrastructure costs. Spark's in-memory computing reduces storage costs and speed up processing times, allowing for quicker task completion and potentially fewer compute instances. Apache Spark is extensively used by organizations, including the 80% of Fortune 500, such as Databricks, Yahoo, and Netflix. For instance, using Spark's in-memory processing for frequently accessed data can lead to faster turnaround times and reduce storage costs compared to traditional disk-based analytics. This is particularly beneficial for tasks like analyzing large datasets of customer transactions in finance. Additionally, Spark's efficiency in handling complex computation can result in significant cost savings. Optimizing cloud expenses is vital for businesses aiming for long-term financial sustainability, but it is a complex task. Additionally, Semaphore CI can be used to streamline and automate cloud deployments, further enhancing cost efficiency. For a comprehensive CI/CD solution that simplifies deployments, consider Semaphore CI Cloud. These tools enhance operations, minimize resource wastage, and ensure significant savings in cloud deployments. If you like this video, please like, subscribe, or follow us for more content. As always, thank you for watching.